Our planet is drowning in plastic. It's everywhere, from the deepest ocean trenches to the Arctic ice caps. A scourge on our environment, a threat to our wildlife, a tidal wave of plastic waste engulfing our world. We've all seen the images: beaches littered with debris, turtles entangled in plastic bags, seabirds with stomachs full of bottle caps. It's a sobering sight, a stark reminder of the damage we're doing to our planet. We've created a monster we can no longer control. But the visible pollution is only the tip of the iceberg. Lurking beneath the surface, a more insidious threat: microplastics. Tiny fragments, less than 5 millimeters long, invisible to the naked eye. They infiltrate every corner of our planet, carried by winds and currents. These minuscule particles are finding their way into our food chain. Fish mistake them for food, and we in turn consume these contaminated creatures. The long-term consequences are still unknown, but the potential for harm is immense. Is there any escape from this plastic nightmare? Amidst the despair, a ray of hope emerges. A beacon of light in the fight against plastic pollution: bioplastics. These innovative materials offer a potential solution, a chance to break free from our addiction to fossil fuels and their devastating consequences. Imagine a world where packaging simply disappears, returning to the earth as compost, nourishing the soil instead of choking it. This is the promise of bioplastics. The story of bioplastics is not a new one. In fact, its roots stretch back far before the age of modern chemistry, to a time when humans first began to observe and mimic the remarkable processes of the natural world. Long before the word plastic became synonymous with synthetic materials, nature had already perfected the art of creating strong, flexible, and biodegradable substances. Early civilizations used plant resins, animal horns, and natural rubber for tools, art, and daily life, unknowingly laying the groundwork for what would one day become the science of bioplastics. It's a tale as old as time itself, rooted in the ingenuity of nature. Plants, with their intricate cellular structures, have always been master chemists, transforming sunlight, water, and minerals into cellulose, starches, and other complex molecules. These natural polymers form the backbone of leaves, stems, and seeds, providing strength and resilience. For centuries, humans have harvested these materials, using them for everything from papyrus scrolls to waterproof coatings. The idea that we could harness these same building blocks to create new, sustainable materials was a vision waiting to be realized. In the 1860s, a visionary named John Wesley Hyatt, driven by the need for a substitute for ivory billiard balls, stumbled upon a remarkable discovery: celluloid. At the time, the world faced an ivory shortage, threatening not only the game of billiards, but also the survival of elephants. Hyatt's inventive spirit led him to experiment with cellulose, the fibrous substance found in plant cell walls. By combining cellulose with camphor, he created a material that was moldable, durable, and could be produced without relying on animal products. This breakthrough was more than just a solution to a game. It was a pivotal moment in material science. Derived from cellulose, a plant-based material, celluloid became the world's first commercially successful plastic. Its versatility was astonishing. Celluloid could be shaped into combs, buttons, film, and even jewelry, offering a glimpse into a future where plant-based materials could replace scarce natural resources. The manufacturing process itself was a marvel, transforming humble plant fibers into gleaming, translucent sheets that captured the imagination of inventors and consumers alike. Celluloid's success proved that nature's chemistry could be harnessed on an industrial scale. It was the spark that ignited the bioplastics revolution, though it would be decades before its true potential was realized. The journey from celluloid to today's advanced bioplastics is a testament to human curiosity and our enduring partnership with nature. As we look back at these early innovations, we see not just the birth of a new material, but the beginning of a movement, one that continues to inspire scientists, engineers, and dreamers to create a more sustainable future. So bioplastics aren't just a blast from the past, they're actually the key to a sustainable future. Imagine a world where the packaging you use every day, whether it's for your morning coffee, your groceries, or even your electronics, doesn't end up polluting the planet for centuries. Instead, it returns to the earth, nourishing it rather than harming it. That's the promise of bioplastics, and it's why so many scientists, innovators, and companies are investing in this technology right now. Unlike their conventional counterparts, which are, derived from finite fossil fuels, traditional plastics are made from oil and natural gas, resources that take millions of years to form and are being depleted at an alarming rate. The extraction and processing of these fossil fuels not only contribute to climate change through greenhouse gas emissions, but also create a host of environmental problems, from oil spills to air and water pollution. Every piece of plastic ever made from these sources still exists somewhere on the planet, whether it's in a landfill, floating in the ocean, or broken down into microplastics that contaminate our food and water. Bioplastics, on the other hand, are crafted from renewable resources, like corn, sugarcane, and even seaweed. These plants can be grown year after year, capturing carbon dioxide from the atmosphere as they grow, and providing a sustainable source of raw material. Some bioplastics are even being developed from agricultural waste or algae, making use of resources that would otherwise go unused. This shift to renewable feedstocks is a game changer, reducing our reliance on fossil fuels and helping to close the loop on resource use. This fundamental difference is really what sets them apart. While both types of plastics can look and feel similar, their environmental impact is worlds apart. Bioplastics can be engineered to have the same strength, flexibility, and durability as traditional plastics, but with a fraction of the carbon footprint. And because they're made from plants, they can be designed to break down much more easily at the end of their life cycle. Bioplastics offer a closed-loop system. They can be broken down by microorganisms, turning what was once waste into a valuable resource. In the right conditions, these materials decompose into water, carbon dioxide, and organic matter, leaving behind no toxic residue. This means that instead of clogging up landfills or polluting our oceans, bioplastics can actually help regenerate soil and support new plant growth. Returning to the earth as valuable nutrients and completing the natural cycle, bioplastics embody the principles of a circular economy. They help close the gap between production and disposal, ensuring that the materials we use today can become the resources of tomorrow. This is a radical departure from the linear take-make-waste model of traditional plastics, and it's a vision that could transform industries from packaging to automotive to electronics. No more mountains of plastic waste, no more microplastic contamination. With bioplastics, we have the opportunity to rethink our relationship with materials and the environment. By choosing products made from bioplastics, we're not just making a small change, we're taking a big step toward a cleaner, healthier, and more sustainable future for everyone. The journey from plant to plastic is a fascinating one, honestly, a real testament to human ingenuity. Imagine for a moment the incredible transformation that takes place, how something as simple and natural as a field of crops can be turned into a material that shapes our modern world. This process is not just about chemistry or engineering. It's about harnessing the power of nature and combining it with human creativity to solve some of our biggest environmental challenges. Bioplastics are a shining example of how we can rethink the materials we use every day, making them more sustainable and less harmful to our planet. It all begins in the fields, where crops like corn and sugarcane are cultivated. These aren't just any crops, they're carefully selected for their ability to grow quickly and efficiently, often using less water and fewer chemical inputs than traditional crops. Farmers tend to these fields with care, knowing that the plants they grow will one day become the foundation for a new generation of eco-friendly materials. The sight of golden corn swaying in the breeze or sugarcane stretching toward the sky is more than just picturesque. It's the first step in a remarkable journey from soil to sustainable plastic. These plants possess a remarkable ability. They capture and store carbon dioxide from the atmosphere through photosynthesis. This natural process not only helps the plants grow, but also plays a crucial role in reducing greenhouse gases. As the sun shines down, the leaves absorb its energy, converting carbon dioxide and water into sugars and oxygen. This is nature's own form of alchemy, turning invisible gases into the building blocks of life. By using plants as the starting point for bioplastics, we're essentially creating materials that are part of the Earth's own carbon cycle, helping to close the loop and reduce our reliance on fossil fuels. Once harvested, the plants are processed to extract their sugary starches. This step is a blend of agricultural know-how and industrial precision. The harvested crops are transported to processing facilities, where they're cleaned, ground and broken down to release the valuable starches locked inside. These starches are the raw material for the next stage of the journey. It's a process that requires careful control and expertise, ensuring that as much of the plant as possible is used efficiently, minimizing waste and maximizing yield. The result is a pure plant-based starch that's ready to be transformed into something entirely new. These starches are then fermented, much like brewing beer, to produce lactic acid. In large, gleaming tanks, specialized microbes are introduced to the starch solution. These tiny organisms feast on the sugars, converting them into lactic acid through a natural fermentation process. It's a bit like making yogurt or sourdough bread, but on a much larger scale and with a very different end goal. The fermentation process is carefully monitored to ensure the highest quality product, and the resulting lactic acid is collected and purified, ready for the final transformation. This lactic acid is the building block of PLA, or polylactic acid, which is, one of the most widely used bioplastics. Through a series of chemical reactions, the lactic acid molecules are linked together to form long chains, creating a versatile polymer that can be molded into countless shapes and products. From compostable packaging to biodegradable utensils, PLA is changing the way we think about plastic. It's strong, lightweight, and most importantly, designed to break down more easily in the environment. The magic of bioplastic creation lies in this seamless blend of nature and technology, a process that starts in the fields and ends with products that help protect our planet for future generations. But how do bioplastics actually break down? Well, it's all thanks to the tiny heroes of the natural world, microorganisms. These microscopic organisms possess the remarkable ability to consume and digest organic matter, including bioplastics. They break down the complex molecules into simpler substances, releasing nutrients back into the environment. This process, known as biodegradation, is honestly the key to bioplastics' eco-friendliness. Imagine a world where packaging simply disappears after use. No more plastic debris clogging our landfills and oceans. Bioplastics have the potential to make this vision a reality. They offer a sustainable alternative to conventional plastics, a way to close the loop and reduce our reliance on fossil fuels. With continued research and innovation, bioplastics could become the norm, replacing their polluting predecessors and hopefully paving the way for a cleaner, healthier planet. The road to a plastic-free future is not without its challenges. Bioplastics still face hurdles that must be overcome. Cost is a major factor. Bioplastics are currently more expensive to produce than traditional plastics. But as technology advances and production scales up, costs are expected to fall. Another challenge is public perception. Some people still view bioplastics with skepticism, unsure of their properties and benefits. Education and awareness campaigns are honestly crucial to dispel these myths and promote the widespread adoption of bioplastics.